Hi class. Okay, so in this video, what I want to do is I want to look at how do you construct a confidence interval. Okay, so we're looking at confidence intervals. How do you construct a confidence interval for a given population? Let's say, okay, so let's say that you've got this population, and you're studying something silly. I don't know, like how many, like the number of slices of pizza. So number of pizza slices per week that the average graduate student eats, right? For graduate students, grad students. Okay, so how many number of pizzas does the average? How many number of pizzas per week? Slices of pizza per week does the average graduate student eat? Okay, and so let's say that we're going to take a sample of graduate students, and we want to know for a confidence interval of, let's say, 90%. So we want to be 90% confident. All right, so confidence interval of 90%. Within what range, if that's my confidence interval, within what range should I find the average to be? Okay. So essentially, okay, so we have this group of college graduate students, and we're going to take a sample. And let's say that our sample size is, we need something big enough to work, so 45 is larger than 30, so that works. So let's say we sample 45 of these college graduate students, and we're trying to find out, right? We're going to take an average of our sample, so there's a sample average. We want to know with 90% confidence that we're correct, what averages fall into a 90% confident interval, right? And then let's say that given that the standard deviation, because this is the other thing we need to know, is 4 slices. Okay, so given a standard deviation of 4 slices, confidence interval of 90%, and we're taking a sample of 45 people. Okay, so let's dig into this. So a couple of things we need to do. The book kind of like gives a little checklist, which I think is good. So the first thing it says check your assumptions. Okay, so the 2 assumptions we need to check is this a simple random sample? And let's see that yes, when we went through and did our sample, it was a simple random sample. And we want to look at the n, right? Is the n greater than 30? Or do we know that the distribution of the population is normal? I mean, easiest thing to check is the sample size greater than 30? And so, yes, it was a random sample. Yes, it was greater than 30. Or they told us that the distribution, that the underlying distribution was normal. So those things I'll check off. Okay. So then the second step, it says, all right, well, we need to find the critical value. Okay. So this is that z alpha halves. And if you watch the video from before, it kind of shows you how to find that. But we'll just run through. It's pretty quick to find. So we want to find a critical value for a 90% confident interval. So to do this, right, here's our distribution. 90%'s in here. That leaves 5% for over here and 5% for over here. Well, this is a value, that's a proportion of 0.05. Okay, so if I then run over to my table, right, if I have on this side 0.05, then on this side I have 0.95, right, because it's got to add to 1, right? The total amount under the distribution has to add to 1. And this table, right, these proportions only tell me what's to the left. So now I want to dig in through here for the 0.95. That's somewhere in between these values here. Okay, so I know that my critical value is going to be 1.6, right, because that's this. Is it 1.61, or no, 0, 1, 2, 3. So it's probably 1.64, right? Because this, so 1.64 has a proportion of 0.9495, and that basically rounds up to 0.95, which is what I'm looking for. So I'm just going to stick with this. 1.64. Okay, so let's hop back. So my critical value is 1.64, right? And that is this z-score here, right? 1.64, and the z-score of this thing is negative 1.64, just for fun, right? As we're looking at that distribution. Okay, so there's my critical value. Now the next thing it says, okay, find the standard error. So that's the standard deviation divided by the square root of the sample size. And for us, we said that the standard deviation was 4 slices, and my sample size is 45. Okay, so gotta get the good old calculator out for this one. So 4 divided by the square root of 45 gives me a standard error of 0.596. Okay. All right, then it says, all right, well, what is your margin of error? So let's see, 1, 2, 3. Okay, so the next one, find the margin of error. And again, if you watch the video previous, it kind of shows you how to go through this, but essentially you just take the critical value, which for us is 1.64, and you multiply that by the standard error, 0.596, and I get a margin of error of 0.978. All right. Okay, so now that I have all of that, I can construct. So let me hop over. So the margin of error is 0.978. 0.978. This is the margin of error. Okay. And then to construct your confidence interval, we need a test statistic. So let's say let's use a test statistic of I don't know, let's say we think that they eat 7 slices in a week, right? 7 slices per week. So what we're going to do is, to build our confidence interval, it's the test statistic minus the margin of error is less than or equal to the mean of the actual mean of the population, our test statistic plus the margin of error, right? And the margin of error goes into that number slot. So for us, we're going to do 7 minus 0.978 less than the actual mean of the population, test statistic, which is 7, then plus 0.978. So 7 minus 0.978 is 6.022 is less than the actual mean of the population. The population mean is greater than that, but it's less than 7.978 when you add those two together. So that is my 90% confidence interval. Okay, so essentially what I'm saying is that if the test statistic, right? So let's say if my sample, the sample I took, so what? I took a sample of 45 students, and the average of my sample ended up being 7. So I can say with 90% confidence that the actual average of the population, right, because anytime you take a sample, you're never going to get the actual average of the population. You're just going to find something that's close, hopefully. And so that's the really cool thing about building confidence intervals. And we can adjust and change the size of the confidence interval based on like how sure we want to be. But with all this being laid out the way that we did, right? With a sample of 45, I can say and getting a sample average of 7, I can say with 90% confidence that the actual average or the mean of the population is somewhere between 6 slices and 7.9 or 8 slices, right? The actual mean is somewhere in between those two values. And I can say that with 90% confidence based on the standard deviation I have, the sample size that I took, right? All of these things play into your level of confidence. So that's how constructing confidence intervals works, right? You have some real population you're studying. Now, this was kind of a silly study. Nobody's ever going to, well, I guess maybe a pizza company might want to do that study. But we're building a confidence interval. Just follow these steps, walk yourself through, and now, and so what we're able to say at the end is with 90% certainty, the real average of the population is somewhere between these two values. All right, we're not 100% certain, right? We're only 90% certain. So that's how confidence intervals work. And if you have any more questions about that, please let me know. Thanks. Bye.